I would guess I'm sort of an accidental robotics instructor. I'm a retired electrical engineer, computer science product manager, worked in the computer industry for years. Um, Retired and ended up working at the University of Colorado. Kat and I agree that uh, the most important thing about STEM education is what do you do after the class? So we try to budget things so the kids get to keep their robot. So they build it, they get attached to it, and they keep it. Because a robot doesn't have wheels. A robot has legs, right? My impression um, of the leg form factor and the dog with a head is that everybody immediately attaches to this as an organic thing. But show them this organic thing can have some behavior that you can design, and they're engaged. And I call these classes an example, an experience in physical computing. So we follow the instructions that Petoi has provided, and just sort of guided them through that. And try to do this together step by step. And of course, that's when chaos ensues because the abilities of a classroom of, I think, what we had 16 people are wildly divergent. So despite all the warnings, some kids couldn't resist, plugged it in, turned it on, and then you hear zzz, and I said, oh no, and then the servo's melting. Now here's a group of boys who decided their Bittle was a weightlifter. So they found, classroom objects like dry erase markers and tape to make them into, and a straw of some sort to make it into weightlifting. Bittle is a weightlifter. Awesome. For me, that's my greatest joy is on the first day of class, I've motivated, some number of kids to take their kit home with them. That's when we're hooked, right? That's when we've created what STEM education wants, STEAM education wants. We want to engage our family, our community, our collaborators. The goal is that we have motivated students who are now exploding with ideas that they're going to play with for the rest of their life.